Hello class, I'm reading 10.1 Probability Distributions of Random Variables. So you should have those notes with you as well so you can kind of read along, and I'll make little explanations as I go. So definition, a phenomenon is called random if individual outcomes are unknown, but the behavior of a large number of outcomes is predictable. So for example, if you're rolling a die being singular for dice, who knows what's going to appear? It could be a 1, 2, 3, 4, 5, or 6. They're all equally likely events. But I do know if I roll this die 6,000 times, approximately 1/6 of those times will be a 1. And 1/6 of 6,000 is 1,000. So I should get about 1,000 ones, 1,000 twos, 1,000 threes, etc., etc. Okay, a random variable is denoted by a capital X. It is an outcome that takes on a numerical value as a result of an experiment. The value is not known with certainty before the experiment. So for example, capital X equals 1 for the experiment of rolling a die. What is that probability? You denote it like this, capital P, parentheses, capital X equals 1, close parentheses, and that would equal 1/6, because there's 6 faces to a die, all equally likely. Alrighty, so another experiment might be throwing a pair of dice. So you got 2 dice, you roll them, and you record the sum. So the smallest sum possible would be 2. You get a 1 on the first die and a 1 on the second die, so that's a sum of 2. And the maximum sum would be 12 if you roll a 6 followed by another 6. There's only one way to roll a 12, so the probability would be 1 out of 36, because there's 36 possible outcomes when you roll 2 dice for recording their sums. You've got 6 choices for the first die times 6 choices for the second die. That's 36 possible outcomes. So it's unlikely to roll a 2, for example. There's only one way to roll a 2, so that way the probability is 1 out of 36. You're going to roll a sum of 2 when you roll 2 dice, because the only way to get a 2 is if you get a 1 on the first die and a 1 on the second die. 7, by the way, is the most prevalent roll. It's the most probable sum to get, because there's lots of ways of getting a 7, 6 different ways. Anyway, that's not as important as what's coming up. And by the way, it's nice to know when you add up all of the probabilities, you always get a sum of 1. It's 100% certain that you're going to roll a sum of either 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. So that's why the sum of the probabilities is 1. Alrighty. Going to page 2 from the notes. Here are 2 key factors for probability distributions. The probability of each event is going to be greater than or equal to 0 or less than or equal to 1. So it's going to be in that range from 0 to 1. And the sum of all the probabilities will always equal 1. Okay, so the next topic in this section is continuous random variables. So that's what the homework will be based on, continuous random variables and the test questions. So when the world gets continuous, calculus meets probability. So the sample space on a continuous random variable becomes an interval along the x-axis, such as A to B. So with the dice, getting back to the dice example, the sample space was discrete. You can either roll a 1, a 2, a 3, a 4, a 5, or a 6. You can't roll a 4.5, so that's why it's not continuous. It's not a continuous random variable with dice. Okay. So the probability that the random variable x will be greater than c and less than d, where x is a continuous random variable, becomes an integral from c to d of your function f of x dx, and will be less than or equal to 1, because that's what probabilities are, less than or equal to 1. A probability distribution function, f of x, sometimes called PDF, probability distribution function, otherwise known as probability density function. So if you have a PDF over the interval a to b, then 2 things must be satisfied. to be a probability distribution function, number one, f of x must be greater than or equal to 0 for all x in the interval a to b. So the graph of f will be above the x-axis, since negative probabilities make no sense. And number two, if the integral from a to b of f of x dx is equal to 1, with those two conditions, then you have a PDF, which means you can ask probability questions, because probability is based out of 1. So the probability of your event happening from a to b of your function f of x d. Okay, just skip that part. Okay, so example. Show that f of x is equal to 4 over 625 times x cubed over the interval 0 to 5 is a PDF, probability distribution or density function. So if you want to show a function as a PDF, you got to show two items. Number one, you want to show that f of x is greater than or equal to 0 for all x in that interval. So let's do that first. So our function is 4 over 625x cubed, and you just note that it is always positive or 0 when x is somewhere in that interval 0 to 5. It's just clearly true by inspection. You don't have to spend much time on step 1, because if x is 0 or positive, isn't 4 6/25 times x cubed always going to be 0 or positive? Checkaroo! So step 1 is satisfied. And then for step 2, let's do the integral from 0 to 5, because that's the interval we're given, of our function 4 over 625 x cubed dx. We want to show that integral is equal to 1. If we can do that, then we've shown that that function, f of x equals 4 over 625 x cubed, is a PDF. And the good news is, if it is a PDF, then we can ask probability questions based on that PDF. And sure enough, as you can see in the notes, when we do that integral, I'm on the bottom of page 2 from section 10.1, we do eventually get 1 as our answer. So that's good. We're done with that. Now that we know it's a PDF, let's use it. So I'm on page 3 now. Find the probability that our random variable x is greater than or equal to 0 and less than or equal to 1. So now this is a subset of our interval. Instead of 0 to 5, we're just going 0 to 1. What will that probability be? Because the whole area is 1 from 0 to 5, we know that this probability will be something less than 1, but it's got to be 0 or higher as well. Remember, probability of events is always going to be between 0 and 1. So the probability that x is going to be between 0 and 1 is going to be given by the integral from 0 to 1 of our function. And when you evaluate that integral, as you can see on the top of page 3, we get 1 over 625. So that would be the probability. There's a picture associated with that. Remember, probability is based out of 1. So because a PDF has an area of 1, we can find probabilities for any subset of that interval. It's just going to equal the area. So the probability for a PDF is going to equal the area of the function on whatever interval you want. Okay, and then for the last example, we've got g of x is equal to 1 over x times the natural log of 10 over the interval 1 to 10. We want to show this is a PDF, so that means we want to show two things. Number one, show that g of x is greater than or equal to 0 for that interval 1 to 10. And because on the interval 1 to 10, x and the natural log of 10 are always positive, that implies g of x is going to be greater than or equal to 0 for all x in 1 to 10. Again, you don't have to show much work for that. So we're done with that step. And now finally, step 2 to show us a PDF is do the integral from 1 to 10 of our function. And if we get 1, then we've demonstrated the function is a PDF. And that's what we did when you look at the notes. Done! Done!